even his eternal power and Godhead, so that they are without excuse.
And we say amen to the Apostle Paul.
Going on to another obvious design quote from Richard Dawkins. Biology is the study of complicated things that give the appearance of having been designed for a purpose. I picked up on that one because of the title of his book, The Blind Watchmaker. Actually, it's a snide takeoff on my favorite original intelligent design man, William Paley. And I never tire of reading this quote from Paley. In crossing a heath, suppose I pitched my foot against a stone and were asked how the stone came to be there. I might possibly answer that for anything I knew to the contrary, it had lain there forever, nor would it perhaps be very easy to show the absurdity of this answer. But suppose I had found a watch upon the ground, and it should be inquired how the watch happened to be in that place. I should hardly think of the answer that I had before given, that for anything I knew, the watch must have always been there. Yet why should not this answer serve for the watch as well as for the stone? For this reason and for no other, that when we come to inspect the watch, we perceive that its several parts are framed and put together for a purpose. Yes. This mechanism being observed, the inference, we think, is inevitable, that the watch must have had a maker, that there must have existed an artificer who formed it for the purpose which we find it actually to answer, who comprehended its construction and designed its use. There cannot be design without a designer, order without choice, subserviency in relation to a purpose without that which could intend a purpose, means suitable to an end, arrangement, disposition of parts, subserviency of means to an end imply the presence of intelligence and mind. And that's what we're pushing for. We're pushing for the intelligence behind all these wonderful designs.
Yes.
And we find it in this word teleology, which Webster defines as the fact or character attributed to nature or natural processes of being directed toward an end or shaped by a purpose. This is a great contrast. Evolutionary concepts promote purposelessness, yes, but creationary concepts promote purposefulness.
Purposefulness, yes, and the designer. Professor Clark, take us now to the heart of the amazing ear.
Well, there are lots of fluid mechanics involved in the ear. We speak, we create pressure waves in the air, and our ears pick those up, and they form a kind of a transducer. I brought along an engineering transducer. In this device, you put a pipe here, which has a oscillating pressure in it, and it come over here on the other side, and you pull off an electrical signal. So this transduces the pressure to an electrical signal. That's essentially what the ear does. We hear these pressure waves bouncing around in the air, they hit our ear, and they, excuse me, they get inside and they go into the brain, and they give us signals that we understand, and in the way the person wants us to. These are some of the complex different wave patterns that we can experience. The complexity of the waves are indicated by their harmonic content, and that's what makes a symphony orchestra sound so good to our ears. And the ear is such a wonderful transducer that it's been said that orchestral conductor, when he has this huge symphony orchestra in front of him, can pick out the one musician who's playing off tune. And that must be quite a feat. I don't think I could manage that.
I certainly couldn't. That's astute.
Here's the essential structure of the ear. We have three parts: the outer ear, the middle ear, and the inner ear. The outer ear over here in this picture is a kind of a collector of sound. We have this thing sticking out here that catches those pressure waves as they're coming forth towards us. If you want to see how much good they do, you can put your hand out here and form a bigger ear, and you can see that you can hear much more that way. But the shape of it is also designed to kind of modulate the pressure waves as they go in, and at the end of this we find the eardrum, and that's the end of the outer ear and the beginning of the inner ear. In the inner ear we have three of the smallest bones in the body, and as you can see, they're really only a little part of this complete structure. And remember, the complete structure only goes from here to about here, so we only have 1.5 inches, 2 inches to accomplish all this complexity. It's necessary for this eardrum to be in a neutral pressure atmosphere. The outside pressure has to be the same as the pressure inside the middle ear, and in order to accomplish that, we have this tube that goes to the inside of our mouth, the eustachian tube, that allows this pressure equalization. Going over to the inner ear now, we have two very complex situations here. The cochlea is the main mechanism, and this is kind of an auxiliary thing to help us in our balance. There's three mutually perpendicular semicircular canals that have little sensing mechanisms in it that allow us to check our balance. And so here is the three different axes about which those corrections take place in our balance.
What a beautiful design. Now, with only moments remaining, let's come to the climax of what you came to tell us. And Professor Clark, in short order, can you deliver the dynamite of design?
Well, the main item here is this canal. The basilar membrane is part of it, and then there are an opening at the top, which is called the oval window, and an opening at the end as it goes all the way around, comes back, the round window. And those are special in themselves, because if we allow a lot of waves to accumulate in here and keep reverberating, we won't be able to tell what's coming on to us next. So this is a real wave absorber over here, this round window. Let's hop over to this picture. This is a photomicrograph of the outer hair cells. There are about 12,000 of these hair cells in our ears, the outer ones, and the inner ones are only 3,500. These are the real mechanism that creates this electrical signal from the pressure waves. This is a cross-section of the cochlea, and we're seeing a plane pass through here. And the main structure that we want to look at is right in here. This is the organ of Corte in here, and here are the outer hair cells, and there's only one inner hair cell here. And if we go over to this picture, we can see that there's a chemical reaction taking place here. I liken it to a battery.
Let me catch you for just a moment. I am overwhelmed. I'm essentially speechless with all the intricate design, the many parts. Removal of a single part renders the entire system unusable.
We're not done yet, though.
Okay.
I mean, we have to get our brain in here yet, because without the brain we can't interpret these signals that are coming at us. And it takes learning from a small child up in order to interpret those electrical signals.
Life experience.
To come over and get into the brain and be interpreted there. So I think in ending, this would be a good statement here. We can say it three different ways.